And also, if you want to go presentation, please be free to ask questions along the way. I'm Kushali.
I'm Lewis.
I'm Megan.
I'm Keon.
I'm Gaurav.
And we're 446.
We don't bite, so
Yeah.
feel free to have
Okay.
Well, he does. He does.
someone earlier,
Watch
so.
it.
Okay, well, I'll be sure to keep an eye on him.
Why don't you tell us a little bit about what's going on, and then if we have questions, we'll interrupt and go from there. That's it.
So the first thing is when we look at this game type, we look at all the different ways to score. Scoring in the pendulum, scoring underneath the pendulum, hanging, flag spinning. And one of the first things that stood out to us was double hanging. It seemed like a great way to put off balance and come ahead of all the other teams. So this is where our first robot came in. Although it doesn't look quite like this one right now, but
So first, we had the rotational drivetrain, which would double hang with the other robot on top of us, scoring 100 points. But we decided that it would take up too many motors, and after scrimmage, we didn't have enough time to make it. So we came to this U-Bot drivetrain that we have currently, which has zip ties on the wheels for extra traction that we saw from snow chains on vehicles with no traction.
See them a lot, don't
Because
Yeah, where did you sit down?
Dr. Curry on snow.
the dreams. Since we're not a heavy robot, we needed the traction so we wouldn't be pushed around. And then this is the Cthulhu intake, the mythological beast. Mythological. The motor turns and the intake spins, pulling cubes into the basket.
So just a quick question about this one. I see you've got one continuous one, right? And I've seen a lot of other ones that were single strand. Is there a reason? Is it different with the? You see this tube. Your tube.
Oh, yes.
Yeah.
Well, we have two tubes actually right now.
Yeah.
If you can see. Well, the thing is that we had surgical tubing with us, and we had different types and stuff, and it's just an occurrence because we had this kind of tubing.
But you went with you left it continuous and threaded it through, right?
Yes.
that way it leaves room for adjustment if we needed it.
Okay. Fine.
Yeah.
So you said it's a double hanging robot.
It was.
It used to
It
be.
was.
It was one of our ways of converting rotational into linear motion. Kind of like the center bar that connects the wheels in the train. We had two roughly 4-inch gears where we attached axles near the center. And by rotating, we were actually able to lift the center platform up 4 inches and get net gain for hanging. Although we weren't able to quite replicate it as we had designed it in CAD, and the end result was that we had to modify our design. It just wasn't competitive enough.
So you had done it in CAD first.
Yes, we did do it.
We have examples in here if you'd like to see.
Yeah. So continue.
Yes. All right. So going through the notebook. Along with after the rotational drivetrain, what we did is after this U-Bot, we actually have a bucket with this dump as well. So one thing that makes us different from other teams is this winch right here. When other teams have actual gears to pull them up and hang, and they're dependent from here. And as you can see, it's just too much stress on these gears. So we have this winch right here, which is connected up here. So when we actually hang, this is what pulls us up. And that's why we can actually hang more efficiently and faster. It takes us 10 seconds max to hang. Because of that, we also have these gears for a reason. We have these gears because we actually need to maintain the weight, because this is actually pretty heavy. So, and the gears are actually functioning so that they move backwards and we can score. If you want to see exactly how, right here. So the cubes go in, we just score backwards. Efficient and fast, basically.
That way, instead of using a 1 to 27, which would have been a lot slower, we decided to stick with 1 to 3. It's just faster. And even though we use 3 motors for our arm now, it's far worth it in comparison to using 2 motors but being a lot slower.
So what happens when one of those rubber bands breaks like this one?
Oh, okay. So for the rubber band, yeah, the rubber bands are actually there so that this doesn't fly backwards, because this is where most of our weight is maintained, and that's why we have this counterweight here, so it just doesn't fly backwards and the robot doesn't fall.
So how many of them can you afford to have break before you fly backwards?
Well, actually, these are quite sturdy. We can have what we started with was 7 on each side, and we doubled to 14. So we usually have about 20, and we can afford about 6 to break.
So, well, as much as that was an important part, this robot costs $2,500, and that kind of money doesn't come like out of thin air. And on top of that, registration and all that stuff racks up a hefty amount of money. Our whole team, which comprises of an FRC team, 3 others, and a VEX team, racks up like, what is it? It's almost $40,000 in a year.
40.
Yeah. And so that's a lot of money. And what we do is all our teams, we work together collaboratively to come up with the money that we need. So even one of the first, I think it was like one of the first or second meetings that we actually had this year, we had a grant day. One of our members' parents actually came in. She worked at Salidas House and was the CEO of it, which is a nonprofit, and she was very familiar with the grant writing process. And she went through with us all the specific points we needed to make, everything that she thought would help us get this money that we needed. And because of that, we were able to write over 40 different grants for different companies. And because of that, we were able to actually raise $10,000 this year. So we're still trying to get that extra money. But in addition to that, we do muffin sales during school, candy sales. We host car washes. We've even done a garage sale on one occasion. All these different ways to help us get the money that we need.
And we also reuse materials as well. For example, we have some lights here I would like to show you. Just 1 second. They sort of light up. Okay, continue. Just continue.
Okay. Well, on top of making money, well, spreading the word, it's a lot harder to get money without spreading the word first around. I mean, but reaching out to the community, just as it's giving back to us, is an important part. So
yeah, we actually do a number of things in regards to community outreach. We give presentations.
Where?
We give them one to Tampa General, actually. We had let some kids drive around the robots. We drove it for them. So we got to have a fun time with that. And then Austin Davis Library. It's a local library branch that me and the former president volunteered at. So we set up a couple programs there, and we gave a presentation, talked about first, and we also, again, drove the robot around for them and let them drive it.
So is it just your team do that, or do you
No,
have
all
with your
3
other
teams.
teams?
Yeah,
They all go together.
We're not Hydra B. We're all Hydra together.
on the competition field, we may be Hydra A, B, and C, but in the shop, we're all Hydra. We're all together.
We're good friends, all of us.
Mostly.
Okay, and tell me about how you deal with the one that you're not friends with.
Well, there's always stuff with management, and actually one of the things we like to do most helpful is we have a Facebook page which we use to keep contact the most. Like almost almost every meeting, we create a little summary that says, well, what we did today. Not only is that good for later addressing and later the hours and seeing what we've done, but it's good and we also host we also have our own website where we do keep updates and
We have a newsletter.
And a newsletter. Yep, and a newsletter that we send out to parents so they keep informed with what we're doing and so that they too feel more involved, just like us. So the Facebook is just an excellent way of communication, so we all keep connected at the same time. We all know what's going on. Even if you miss a meeting, you can just check.
And also now we have a Facebook page where you guys can check it out as well, Hillsborough High School Hydra. And you can go on there, we can see our progress, videos we update, we have YouTube accounts that people can go in and see. We have 79 subscribers right now, which I don't think is pretty bad, it's pretty good.
40,000 views. It's
Yeah.
one of the most for any FTC channels out there, actually.
So it's really good.
And you were saying, going back to community outreach.
Oh yeah. We do a number of different things. Another thing we do, we have a t-shirt cannon, actually, and we got home football games, and we shoot t-shirts. A lot of people don't think their high school robotics team can actually do that. We designed it, we built it ourselves, former members built it, and we're in the process of keeping it. And a lot of people only recognize that to the school, know we exist because we have a t-shirt cannon, and they see us every Friday. So it's good recognition for us, and they get to be involved with us because they shoot them in the face with t-shirts. So.
At the same time, we do a lot of professional outreach at the same time.
Yeah, for example, one time we went to a bar camp convention where we got to talk to a lot of professionals in the field, and we got to talk to them about FIRST, and we got some more money and professional help from them.
I mean, we had a table right inside the lobby, and we were able to connect face to face with all these people that were already in the engineering field. And there's actually a couple people who we actually later saw different competitions. We said, well, we had this competition then, and they said, well, maybe I'll show up, and they did. And it was a great way to form connections with people. And like Gaurav said, we actually got, I think, $200 worth of sponsorship and extra motors for off-season builds from that as well.
And we also work as a team every day. Well, after like funding and everything, we also have professional help from Mr. Jordan, who comes in and actually helps us. He's one of our members' dads, and he's an engineer. So he helps us, and he told us ideas like, the rotational direction is not working for you guys. Why don't you try this or stuff like that? So he's really great at helping us, and we really appreciate it.
And then we have another man who comes up with Mr. Swigger. He's a retired engineer from Lockheed Martin. He mainly helps us with FRC. But, a lot of things he tells us there we can apply later on. A lot of it's, kind of just general ideas for building and planning. So we have a number of people who come and help us. It's not just us. They guide us there. Look at us.
Any questions?
Tell me about autonomous.
Oh, okay, that's on the other side of the robot. Okay. So, here on this side of the robot, we have a single autonomous arm. So given that we had a very compact space, there's almost like 3 inches here, but we had a lot of vertical space, so we're thinking, well, as much as that is good for deploying an arm forward, why don't, if we put 2 motors together, we can actually have an arm be deployed outward and then forward. So what this does is it allows us to, as we have our IR sensor down here, we have a program. Gaurav, actually, Gaurav is the one who's all the master with code here, so he can describe it.
First, we initialize the service at position, and once the match starts, the servo raises. It goes forward until the IR sensor detects the IR beacon. The arm swings forward, scores the cube, and then the robot proceeds to go forward, turns twice, and parks on the ramp for the total of 60 points.
And also, just quickly, even though, as Lewis said, Gaurav is actually really good with code, we all work together on everything. So, for example, Gaurav right now is teaching me code because I'm sort of like a newbie. We're in a programming team together, things like that. And also, for example, I've taught Megan about electronics, which are in here, which we've made so that they're compact and things like that. And even though these things are like the hardest to work with, we actually have our team work with mechanics all together. So this whole robot is not made by one person, not our team captain, it's made by every single team member together.
Even though during a meeting, sometimes we have like 2 members, and like on Fridays we have like 8. So sometimes it's a bit difficult dividing up the work. So what we do is actually to construct stuff modularly. Like say, okay, for example, like I said, like Megan and Kushali, why don't you guys work on electronics while Gaurav is going to work on code and test some autonomous, and then like say Kian and I, and there's some members not here, like for example Ravi or Camille, and we just take small parts and say, well, we have to fix this, so you guys can work on that while we work on this. And it's a great way that we can all be working on something and all feel involved, and at the same time get a lot of progress done.
I'm guessing that was our
Yeah.
Oh,
that
those
was
are
our hint that we were
Sorry,
overcoming.
can I wait? Okay. I got just one last
Yeah, sure.
question, then you can leave. Who's the person who put the Devilman sticker on?
Well, yeah, we
See?
even have been sponsored by Valve.
We've been sponsored by Valve. I was going to put an Aperture sticker on there, but someone was stopping me. And we actually all play Team Fortress 2 and stuff like that, so yeah.
Yeah.
We're really close.
Aperture Science Innovators.
Yeah.
Who would stop such a thing?
My car in the parking lot is too many Manglo stickers as it is.
Very good. Thank you, guys.
Okay, well, thank you for being here.
Thank you very much.
Thank you very much.
Okay.
Thank you again.
Good luck next door.
Oh, we
And
have
one
a
more
one thing to say.
Just like on the back of a robot. Are we ready, guys?
Yep.
Ready? 3, 2, 1. Uno, dos, y tres! Olé! Right here in the competition. You're doing off.
Yes. And it's louder because there's carpet here.
Microphone.
All right. Thank you very much.